Morning, everyone. I'm Joe from Megapixel. I work on the product marketing team. So I'm going to talk today a little bit about some of the benefits of SMPTE 2110, certainly for large-scale LED deployments, and a little bit of the history in virtual production as well, because that's very much kind of where a lot of this started for us. So to understand the future, we really kind of have to look at the past. So virtual production as a term has been used a lot in the last couple of years, but we've been doing it right back until about 2005. So back in 2005, the co-founder of Megapixel, Jeremy Hockman, worked on a music video with Coldplay called Speed of Sound, and this was actually the first use case of video-driven LED lighting fixtures used as key light. And that's 2005, not 2015. This about 20 years ago. And after the success of that particular project, the DOP from that project worked on a film called Zodiac with David Fincher, and they did a very similar workflow where they used video-driven LED key lights for reflections and lighting effects on cars. And this wasn't a case of LED being used in camera like you see today. This is purely for lighting, reflections, things like that. As things progressed, curious case of Benjamin Button in 2008. After the success of those first two projects, things started to get a bit larger. So this was a whole LED tunnel that was done with LED key light as well. And again, we're still not at the point of this being in-camera VFX like it is today. And Jeremy actually had kind of wrote a media server on his MacBook Pro, and this was running at like a 1024x768 resolution, which nowadays would be super low res, but back then was actually ultra high res. And then moving on, 2013, we did Gravity with a light box, and this is kind of the first kind of iteration towards the workflows that you kind of see today. This was an earlier example of a project where you needed lots of key light on the individual, but you had things like reflective visors and things like that. The same kind of problem that Mandalorian dealt with many years later. That's very, very difficult to pull off in post-production. So doing it with LED panels and using the panels as key light makes a lot of sense because you don't have to deal with those problems later on in post-production. And then moving on, 2016, Star Wars Rogue One. This was kind of the first very large wraparound volume. And again, we weren't quite at the point of using this for full in-camera VFX. Again, this was used for lighting effects specifically in the spaceship and the outside atmospheric effects of the spaceship. And you can actually see in the middle there's a very long shower curtain that they used to kind of basically hack together some of these lighting effects. And if it looked good in camera, then that's all good. And this was very much still the Wild West of you just kind of do whatever works so that it looks good in camera. It doesn't really matter how you go about doing it. Curious. Murder on the Orient Express was another large-scale LED deployment. This was kind of the transition from using LED as key light to actually using LED as a in-camera capturing the pixel for the environment outside of the train. And this was a dual 8K video raster, so this was the first time that you kind of gone to really large-scale resolutions. So we had to kind of build equipment and workflows that matched up to that level of pixel processing. First Man was kind of the first wraparound in-camera LED volume that was used for what people like to call final pixel. It wasn't all final pixel. There was some stuff done in post, but the volume was used to capture a lot of the environment around the plane that you would actually see in the film. And this is a lot more akin to what people are doing with volumes today. But actually, to do this kind of thing, you kind of needed that whole history, right back to 2005, because we've been building the workflows and the knowledge around how this stuff works, way before we ever got to doing volumes, of this particular size. So, fast forwarding to today, the volumes of today are utterly huge. I mean, Trilith in Atlanta, Nant in Australia. Nant actually has over 4 billion pixels and runs on just over 50 of our Helios LED processors. And really, we wouldn't have been able to build projects like that unless we had all of this knowledge going back 10, 15, 20 years from the other projects that weren't necessarily doing in-camera VFX in the same way that we are today. So that's a little look at the past. That's been a long, long time in the making. There's a lot of pain points with these projects. You've got to move a ton of video data around. You really need bidirectional data. There's lots of pieces of equipment in the pipeline that really need to talk to other pieces of equipment, which in a baseband system, you can't. It's very one-directional communication, which is not great. And there's a lot of connections and conversions that need to be maintained and trusted for things like metadata and other attributes to be passed between them. And that's only a very small example. Metadata is quite a common thing today, but in reality, there's probably lots of communication that could be improved if these systems all talk to each other in a more cohesive fashion. So how do we go about doing that? Well, number one, network-based systems. And then our Helios LED processing platform is built on a network-based system as well. So we actually predicted the kind of evolution of this, 10 years ago. This project is MGM Macau, and this is a very, very large deployment of 4K video rasters. At the time, it was the largest indoor LED deployment in the world. That's been surpassed recently, but the nearest processor to the screens was actually well over a mile away. So the only way you could do a project like this was moving to a network-based, a fiber-based infrastructure, which at the time was still very novel. I mean, you just couldn't do these kind of projects on a baseband system because the panels were far too far away from the control room. So we had to build a fiber-based system. And a traditional data path looks a little bit like this. You have footage that goes into a media server, into a video router, into a processor. It's all gen-locked together. If you're doing virtual production, you'll have a camera in there as well. And eventually, all of the content ends up on a display of some kind. The challenge is that adds a lot of different points of failure. And if you're converting and doing this over large distances, you're probably going to add quite a lot of latency to it as well. The benefit of a 2110-based system is you completely remove the need for a video router because your network switch effectively becomes your video router. And you remove a lot of the points of failure and points of additional latency in the system that you would have had with something that was baseband. So we launched last year a 100G fiber input module for Helios. It's capable of ingesting 8K natively. You can do 4K 60 rasters as well to combine 4K images into a single 8K if you want to do that. And we also support up to 32K panorama. So because Helios is bandwidth driven rather than raster driven, we don't really care how you use those pixels. You could do 32K wide by 1K tall if you wanted to. We're not limited by the normal 16:9 resolutions that a lot of video processing platforms are limited by. When we launched this, we actually pre-tested it with Matrox, NVIDIA, and Unreal, so that because 2110 is very new, when you got it out of the box, it was going to work with some stuff right off the bat. It's been pre-tested manufacturer to manufacturer, which is really important because we're still quite early on in the adoption of these systems, and it can still be a challenge to get them up and running. So pre-testing this stuff with partners is really important to making sure the end customer experience is really good. So some of the benefits of the 100G card, reduced latency. Certainly for virtual production, latency is a big deal. The more latency you can remove from the system, the better for the most part. Certainly true in traditional broadcast applications as well, although in those applications you can generally manage the latency a bit better. There's less interconnects, there's less points of failure, there's less piece of equipment that can go wrong, there's less long-term maintenance. It's all running on a single network backbone. There's more reliable metadata as well. I mean, certainly, for things like content and cameras, they often need to pass data between, the LED processor or the media server, and being able to do that and do those handshakes nicely can really only be done, in a network-based environment. You can't really do it any other way. And you get a lot of robust IT-centric monitoring as well. We have a platform called Omnis, and that's able to monitor in real time pretty much an unlimited number of Helios processors. So you can get a very good view on what's going on in the system. And that's useful for things like virtual production and broadcast, where you're very time limited. If you have to stop using the stage for a period of time, that can be very expensive. And it's also useful for the fixed install applications, where actually you can tell if a pixel is out on a screen, and you can schedule maintenance at a time that is not disruptive to the environment that the screen is actually in. And ultimately, there's loads of other systems that really video needs to interact with that if it wasn't network-based, you wouldn't be able to do. So, audio, lighting, rigging, comms, projection, even things like pyro and fog, not necessarily on networks today, but I think long-term will end up on networks. And the only way you could have any interoperability with those other systems is by having it on a network. So, the infrastructure that's being rolled out with 2110 eventually, I think, is going to involve lots of other, departments so that we can all benefit from being network-based. This was an example of a project we did with Adidas and Prada. This is very kind of solutions-orientated, but the networking infrastructure gave us the flexibility to deploy the technology in a way that perhaps we wouldn't have done before. If this was baseband and there was a whole load of copper cabling in there, the robots probably wouldn't have been able to work in the same way that they were able to work with a network-based infrastructure. So drastically minimized cabling, which is really cool. And that's an example of what you can do when you move away from a baseband system to a more network-based system. This was Fox NFL Sunday. This is a broadcast studio that is running on 2110, and this is a combination of the work that we've done with 2110, as well as effectively the in-camera VFX stuff from the film world now being used in a broadcast virtual production environment. The extensibility of our APIs was really helpful here. This is running Ghost Frame as well. So being able to link all of that together to provide an end product for the client is really a testament to the way the platform is built, and you can build things around it using the APIs. That again, with a baseband system, you're quite limited with what things can and can't do. Whereas with a network-based system, you can extend it and add bits of interoperability with other systems that you wouldn't have been able to do before. And that's us. We're doing a lot of work in 2110. We've got the 100G card available now going forward. Any questions around SMPTE 2110, 100G, please let us know. And yeah, thank you.